Hello and welcome to Design and Implement Branch Strategies and Workflows. I'm Andrew Conniff, a Microsoft Technical Trainer specializing in data and AI. In this session, we will explore how to design effective branching strategies and implement workflows in Azure DevOps and GitHub. So let's dive right in. Branching strategies are essential for managing code changes in a collaborative environment. They're going to define how developers create, merge, and manage branches in our version control system. So a well-defined strategy ensures that teams can work on features, fixes, and experiments without disrupting the main code base. So feature branches allow developers to work on new functionality in isolation. This minimizes the conflicts and makes it easier to review the changes before merging into the main branch. By using pull requests, teams can enforce code reviews and automated checks, improving the code quality. The feature branch workflow is the best practice in modern DevOps, where all feature development occurs in dedicated branches rather than in the main branch. And this approach allows developers to work independently on new features, minimizing the risk of disruption to the main code base. So by isolating the changes, teams add the commits, we can open pull requests, and we can review the code collaboratively before merging, ensuring that only the validated and high-quality code is integrated into the main branch. The GitHub Flow is a lightweight, branch-based workflow designed to streamline collaboration for all contributors, not just developers. The process begins by creating a branch in your repository, allowing you to make the changes without affecting the default branch. This isolation gives our collaborators the opportunity to review the changes and provide the feedback. And then each commit should represent a complete isolated change, making it easy to revert if necessary. So the workflow encourages frequent commits and pushes, ensuring that the work is backed up and visible to the team. Once the changes are ready, you can create pull requests to invite feedback and discussion from your team. Reviewers can suggest improvements, and automated checks can validate the code before merging. And after approval, the pull request is merged with the main branch, and the feature branch can be deleted to keep the repository clean. The fork workflow is a common approach to open source projects where each developer works within their own server-side repository. So in this model, contributors have both a private local repository and a public server-side repository, allowing them to make changes independently before integrating their work. This setup reduces the need for everyone to push changes to a single central repository, making the collaboration more flexible and scalable, especially for large distributed teams. Forked repositories are typically managed using a standard git clone command, which helps streamline the process of copying and working with the code. By using the fork workflow, organizations can encourage contributions from a wide range of developers without risking the stability of the main code base. This method is particularly effective in public open source projects where many contributors may only occasionally submit changes. The separation between private and public repositories ensures that code can be reviewed and tested before being merged, and supports better code quality and project governance. Azure DevOps and GitHub use branch protection policies to ensure code quality and collaboration during merges. In Azure DevOps, you can require a minimum number of reviewers, check for linked work items, enforce comment resolution, and limit merge types. Additional constraints can include build validations, status checks from other services, and automatically including designated reviewers for specific code areas. These policies help teams maintain high standards and prevent unreviewed or problematic code from being merged. GitHub offers similar branch protection rules, such as requiring pull requests before merging, passing status checks, resolving conversations, signed commits, and successful deployments. Options like requiring linear history, locking branches, and restricting forced pushes or deletions further safeguard the repository, and these controls ensure that only thoroughly reviewed and validated code is integrated, supporting reliability and secure development workflows in both platforms. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.